Hello. Okay, so this is part 2 of proving fundamental trig identities. So again, we're going to reference this chart a number of times. We went through a couple of problems already, but a reminder to pick the more complicated side and try to make it look like the other side. Okay. All right, so let's try to take a look at this first one. I think this time I'm going to zoom in a little bit. Okay, so it says 1 plus secant squared theta plus sine squared theta. We have to make it look like secant squared theta. Okay, so I don't always know where to go with these, but one thing that you have to keep in mind is these two things are tied together. So you can't separate this from this thing right now. So a lot of people are tempted to like just put this together. You can't do that, so be careful of those types of things as you're trying to navigate and keep your rules of algebra in mind as you're doing that. Okay, so one of the things that I look at here is I'm just going to try some things. I know that secant is also 1 over cosine, so I could maybe try to start there. So I'm going to see if I can rewrite this as, since it's not secant, it's secant squared, I'm going to have to write cosine squared theta. And again, where do I get that? Okay, right, that's this right here. Okay, so that's my first try, and sometimes, like I said, you might go down this route and it might not work. Okay, so let's if you want to put that over 1 so you don't get confused about where those go, that's fine. So now I have, if I'm looking at these two, I have sine squared theta on top. Sine squared theta times 1 is sine squared theta. And then on the bottom, I would have cosine squared theta. Now, sine squared, or sine over cosine, remember is, let's go back up here, sine over cosine is tangent. Okay, so I'm going to use this property to help us out. So it's squared, so I'm going to have to rewrite this as 1 plus, this is tangent, but now tangent squared because both of these are tangent squared. Okay, now this looks kind of familiar. This looks like a Pythagorean identity. So as we look here, you'll notice, I see that right here, tangent squared theta plus 1 is equal to secant squared theta. So really we've got this. It's tangent squared theta plus 1. That's what we have here. It's just reversed, but it's still equal to the same thing. So I end up with this is equal to secant squared theta. And remember, that's what we wanted it to be right here. So my last line should also say the same thing, is that this is equal to the right side. Oops, secant squared theta. Ooh. And now I've got it. Okay, I've just proved that identity. And sometimes you're going to, like I said, go down the wrong track and the wrong path, and that's okay. You might have to start over and try a different one. Proofs are not easy. These are a little bit challenging. Okay, let's try another one. I'm also going to zoom here in a bit. And for this one, I'm not going to go up and down, as that might be a little bit tricky. I'm just going to start replacing some things. So I see cosecant here. When I look at cosecant, I know that's the reciprocal of sine, so I might want to start there just because I know the left side is already sine, so that might be helpful. Cotangent, it's the reciprocal of tangent, or I could write it with the cosine over sine instead, and because I've got a sine on the left, I'm going to do that. So I have cosine theta over sine theta. And then, okay, there we go, times, what do I have left? Well, cosine theta, I'm just going to leave that alone for now. Okay, so again, these two things are multiplied, so I'm going to take care of that first because I can't separate that from the subtraction. So I've just got 1 minus sine theta, or 1 over sine theta, excuse me, minus, now cosine theta times cosine theta is cosine squared theta over sine. Okay, Well, right at this point, I don't see a whole lot that I can do, except I notice I'm subtracting two fractions, and they both have a common denominator, which is sine theta. So then that means I can put this denominator together and just write this over sine theta on the bottom. So that means the top then would be 1 minus cosine squared theta. Okay, so now I've got to do some navigating a little bit. I do know that if I look at my trig functions or my Pythagorean identities, I'm actually going to write this in a little bit different color over here. I know that cosine squared theta plus sine squared theta is equal to 1. So now I kind of have this here. If I subtract cosine squared theta from both sides, I end up with sine squared theta is equal to 1 minus cosine squared theta. So that means this right here is the same as the top of what I've got over there. So let's kind of finish this off here then. So really, this is equal to the top instead is now going to be sine squared theta over sine theta. Okay, well, that's pretty good because I've got sine squared theta and a sine. Remember, sine squared theta is sine theta times sine theta. So our sine, one of the sine thetas is going to cancel out. Whoops. So we're going to be left with sine of theta. Now that's what I wanted on the left. I wanted this to equal sine of theta. So there's my final line. And I've just done another proof. Okay, we're going to try one more to just hopefully help you understand this a bit, as this is a little tricky. We're trying to take it slow here, but okay, last one. So prove this identity right here. And when I'm looking at this one, I don't really have a whole lot I know other than there's some things that they all have in common here. I can rewrite all of these in terms of sine or cosine or a combination of both. So I'm going to try doing that and see if anything pops up. So secant, let's try. Secant is 1 over cosine. On the bottom I still have cosine. Okay, minus tangent. I could write it in terms of cotangent, but I think I'm going to rewrite these in terms of sine and cosine. And then hopefully maybe something cancels out. So tangent is sine theta over cosine theta. And then cotangent is cosine theta over sine theta. Okay. And I'm trying to make this look eventually like 1. So how the heck is that going to happen? Well, first of all, here, let's take a look at this first fraction and just deal with this individually first. So I'm going to do some work up here. So if I have 1 over cosine theta divided by cosine theta, that's the same as multiplying by the reciprocal, which would be that. So if I multiply those, I get 1 over cosine squared theta. So instead of what I have as this first fraction, I'm going to write that now. Let's go back to red. So this is now 1 over cosine squared theta. Okay, so let's try to do something similar with the other one. I've got sine theta divided by cosine theta, and then divided by cosine over sine. So I'm going to multiply by the reciprocal. Now, here, you'll notice on the top, I'm going to get sine squared theta. And on the bottom, I'm going to get cosine squared theta. Okay. So let's write that. Now it looks like some things are opening up for me here. These are kind of proofs, or kind of like puzzles. Okay, so now I have this similar thing here where the denominators are both cosine squared theta. So I can rewrite this as, on the bottom, cosine squared theta. The top will now be 1 minus, sine squared theta. Okay. All right, so now let's go back to that same theorem. You know that cosine squared theta plus sine squared theta is equal to 1. That's one of your Pythagorean identities. So now if I subtract cosine squared theta from both, if I subtract sine squared theta from both sides, I would end up with 1 minus cosine squared, or 1 minus sine squared theta is equal to cosine squared theta. And I'm going to write that out. Okay, so again, just subtracting this from both sides, and that's what I'd end up with. So now we can see that that is right here. So the top is actually cosine squared theta, and the bottom is cosine squared theta. So now we know that that is 1, and that should equal the right side, which we set up here is 1. So I'm going to write that, and that's my answer. Okay, so it's a little bit more examples to help out. Hopefully it does. I know it's a little bit longer, but these take some practice, so I wanted to make sure you had plenty of help. Okay, hope it makes sense. Good luck on your assignment, and email me with questions. Take care.